Hello and welcome to this very first Gideros video tutorial. I'm going to tell you about Gideros and its various components, how to install the software, where the various parts of it live and so on, and we'll write a very simple demo app. Now if you don't already know, Gideros is an open source 2D game engine, so it's free and open source and it allows you to write games for a variety of different operating systems, including Android, iOS, desktop, Windows Phone, and you can also export to HTML5. The first thing you're going to need to do is to install Gideros, which of course is completely free. Go to the giderosmobile.com website and you can go and download Gideros. Gideros is available for either Windows or Mac. So just click here and you'll download the latest version of Gideros, which is currently 2015.12, and just click on the installer and follow the instructions, and it will install at your start menu, or the equivalent for Mac OS X. When you install Gideros, it appears in your start menu. I want to talk a bit about what these various things are within the Gideros group. Firstly, there are two forms of documentation in the form of HTML files called Getting Started and the Reference Manual. The Getting Started documentation is what we're going to go through today in this tutorial. Basically, it tells you how to create your first project, add code to it, and so on, and add assets. And our aim today is to go through and write a very simple app of this sort, which will just be a ball bouncing on the screen. The other important documentation that's within the installation group of Gideros is the reference manual. Both of these documents are available online as well on the Gideros website. The reference manual tells you how every single Gideros API works. And there are many of them, but as you become more experienced with Gideros, you'll come back to this reference manual and you'll figure out what the exact parameters of each and every one of the APIs is, what its inputs are, what return value it has, and what it does. So everything is documented in detail here. But to begin with, you want to start with more of a tutorial introduction to see the basic concepts, which is what we're going to do today. What else is in the group on the start menu? There are two very simple programs called Gideros Font Creator and Gideros Texture Packer. As I say, these are very simple programs. They're kind of like auxiliary programs that you will use occasionally. So the texture packer lets you take all these bitmaps. You have a lot of bitmaps. You don't want to import them all as different files within your Gideros game. Rather, you want to put them all into a certain texture atlas, which is like a big bitmap which contains smaller bitmaps. And this is more memory efficient and more convenient to program. You can see these programs are very simple. I won't go into them today, but I just want you to be aware that they exist. But they're very much simpler programs that you use to help you with small aspects of Gideros programming. The other one is Font Creator. You import a TrueType font, TTF font, and you can export a bitmap font. These days, Gideros can actually deal with TrueType fonts directly, so you may want to, you may not need to use this Font Creator because it can deal with TrueType fonts directly. But you can also import bitmap fonts. And if you want a bitmap font, you can create it this way. So I won't go into these two simple programs today. I'm going to focus more on Gideros Studio itself, which is by far the most important program out of all of them. So that's all there is to it. There's a license manager, but you don't need to use it at all because Gideros is now completely free and open source, and you never need a license to run it. Gideros Player you can launch from here, but actually you normally would launch it within Gideros Studio. Let's do that. Let's launch Gideros Studio. And how do you launch Gideros Player? You launch it from here. Start Gideros Player from this icon. I'll tell you about Gideros Player in a minute. First of all, let's have a look at what Gideros Studio shows you when it first starts up. You can see all the recent projects that you've been working on. You can also see a large number of example projects. You can just click on these, or rather double click on them to load the example project. I'm not going to look through the example projects today because I want instead to type our own project from scratch. So I want to start with a blank sheet and type our own project, but it's very useful to look through all these different example projects, which are divided into various groups: graphics, 3D graphics, shaders, audio, hardware, networking, physics. Gideros has a built-in physics engine, so you don't have to write that. You can have a game similar to Angry Birds, and you can write it very easily within Gideros without writing your own physics-related code. So these are all the different example projects. The other things you'll see on this menu, this start screen rather, getting started will take you again to the getting started documentation, which I've shown you, and which we're essentially working through today. And the reference manual is also available again. Now we want to create a new project today, start our new project, and we're going to create a very simple project from scratch. You can either use this button, or you can use the file menu. Let's use the file menu just for fun. File, new project. Okay, browse. Let's browse to where we want to store our new project. Of course, it must be a directory that you have access to. I'm going to store my new project in D Gideros and then examples. So because create folder for project is selected, it will actually create a new folder. So within Gideros examples, it will create a folder. I'm going to call my project Hello Ball, because I'm going to create a ball and make it bounce around on the screen. So it'll create a new directory called Hello Ball, and within that directory, it will create a project called helloball.gproj. This is the Gideros project file. Let's click OK and zoom out of that, and you can see that we have an empty project here, and that's what it looks like. What I need to do now is add some files to the project, which is currently completely empty and doesn't do anything. To do that, I want to borrow some files from an existing example project. So if I go back to the Start menu, go to Gideros, and choose the examples, you can see I have all the files from these examples, some of which I've already shown you. And these are the examples that are available right at the beginning when you go to the Start screen of Gideros. I'm going to go to the graphics group and go to jumping ball. I'm now going to just grab and borrow two graphics from this example project, which I'm going to copy across. So now within my folder, Gideros examples hello ball, that's where I'm creating my new project. You can see it is a Gideros project because I have a gproj file here. And I also have two different bitmaps. Now if you go to Gideros, you can see it's not aware of these bitmaps yet. In order for Gideros to be aware of the bitmaps and add them to the project, I must manually add these bitmap files, these ping files, to the project. To do that, I right-click on the root of the project and choose Add Existing Files. I then select both of my files, because I want them both to be within this project, and select Open. So you can see my project now consists of two files, and I can actually right-click, I can just left-click on these files to get a brief overview in this preview window of what the picture looks like. I can also resize these various panels, as you might expect. There's an output window down here as well. Okay, now to make something happen, to make some sort of app or game, I need to add some code to the project. The code in Gideros is written in a language called Lua. Now I'm going to add a new file, and I'm going to add a Lua file. Traditionally, the main program of Lua in your Lua project will be called main.lua. Larger projects will consist of several Lua files which call each other, but the entry point is typically in the file called main.lua. Let's select that file. You can see main.lua is now added to the project. If I double click on it, I have an empty file which I can start to edit. At this stage, it may be useful to simply have a quick look at the gproj file, just to show you there's no magic going on. The gproj file is just a text file. If I double click on it, I can open it, and let's make sure I save the file before I do that. You see the project has an asterisk, meaning it hasn't saved what files are in it yet. I need to use this save all command to save the project. The project now knows that it has these different files within it. Let's try this again. Actually close this one down. This is where I copied the files from. If I look at helloball.gproj, you can see it has several files within it. And it knows that there are several files associated with this project, so the project consists of just of these 3 files. So you can see there's nothing magical about this gproj file, it's just a simple text file. And that's all there is to a Gideros project. A Gideros project consists only of a gproj file and whatever assets you've added to it. Gideros does not generate hundreds of binary files all the time every time you click on something. It doesn't auto-generate any files except for the gproj file. And the gproj file is a simple text file. And actually this is very convenient when you're using version control. So when you use version control like Git or GitHub, you want to share projects with other people, work collaboratively, it's very convenient the fact that Gideros doesn't automatically create binary files. You can see what the gproj file is and you can commit it onto GitHub. You can see what your main.lua is. It's just a text file which you can edit yourself. So Gideros has a very clean, simple project structure. Alright, let's start adding some code now. I've opened my main.lua file and I'm going to write some code. I'm going to write a new variable called background. And this background variable is going to be a bitmap. To create a new bitmap, I use the API bitmap.new. And you can see the IDE is automatically completing this for me. Bitmap.new takes a single argument, which is a texture. Now, how do I create a texture? Well, I need to use texture.new. And that also takes a single argument. Actually, there's another argument, but I'm only going to use one argument. And the single argument it uses is the name of the bitmap file. In this case, I want my background to be my file field.ping. So now I've created a bitmap. Actually, I could have done this in 2 stages. I could have said texture equals texture.new field.ping. I could have done that. And then I could have used that new variable to assign the bitmap. So I create the bitmap from the texture that I've created already. So you can do it like that, and there's nothing wrong with doing that. But it's generally considered simpler to do it all in one command, which of course you can do. So let me do that. I'll put it back to how it was before. So background equals bitmap.new texture.new field.ping. So that creates a bitmap, and a bitmap is a visible object made out of bitmap data, such as a ping file. That's then the entirety of my program so far. Now to see the program running, I must launch Gideros Player, which I do from this icon. Gideros Player represents how your app will look when it's running on a mobile device, or indeed on a desktop device. So whichever device you're running it on, it gives you a preview of how the device will look when it's running, how the app will look. I now want to change this resolution to 320 by 480 resolution, which is the resolution that iPhones used to be many years ago, but it's kind of a standard resolution just to start off with. It's kind of the default resolution people use. But you can, of course, use different resolutions. For now, I'm going to try a 320 by 480 resolution. And I'm going to run my app on this screen, which is 320 pixels wide and 480 pixels deep. So here's my screen, and this is just showing me what my Android device will look like, or my iOS device, or my iPad, or my Windows Phone will look like. Whichever device it is, this is what will appear on the screen of that device. Let's run it. Nothing happened. I have a blank screen. The reason is that I haven't yet added my bitmap to the stage. The stage is a very important concept in Gideros. The stage is a pre-existing variable, which is a global variable, and I can add things to it. What I'm going to do now is I'm going to add a child to the stage, and the child will be my background. Once I've added the background sprite to the stage, it's a child of the stage, and it will be drawn on the screen. Everything that appears on the screen must be a child of the stage, or indirectly a child. So for example, now that I've added the background, my background can have children of its own. So what I can do is I can group a whole load of sprites together and rotate, translate, or scale them as a single entity. This allows me to build up more complex graphics. But for now, I'll simply add the background directly to the stage. Now that I've done that, I should be able to see the bitmap appear, and so it does. So now I've got a simple app that consists of a single still picture which fills the entire screen, and it happens that my bitmap is 320 by 480 as I wanted it to be. At this point I should mention that there are many things I can do with my bitmap having generated it. So background is a bitmap, but there are many different methods I can use for it. I can use setX to set its x coordinate. Now you can see I've shifted the app along. I've shifted my bitmap to one side by setting its x coordinate. And you notice when I made a change to the code and ran it, I simply have to press the play button again. I don't need to recompile anything. Of course, I can also set its y coordinate. Let's set that to 50. Now notice when I type a bracket for one of these methods, it tells me what arguments it expects. That's the wrong one. For sprites, it sets the y coordinate of the sprite. So whatever y is will be the y coordinate of that sprite. If I run that again, now I can see that my sprite is positioned at 100 pixels along and 50 pixels down. So these are just two of the methods we have for sprites. Now you might wonder what point on the sprite is actually being set when I set 100 by 50. You can see it's the top left corner of the sprite that's being set. When I set it to coordinate 100 by 50, I'm setting the top left corner. But I can actually change that if I want. It might be that I want to control the central coordinate. It's more natural for me to control the central coordinate of the sprite. If I want to do that, I can set the anchor point of the sprite. So let's experiment with that. Background, set anchor point. Now it takes two numbers, both of which are between 0 and 1. If it's 0, 0, well that's the default. That means when I set the position of the sprite, it will be at the top left corner. If I set it to be 0.5, 0.5, it will set the central point. Let's have a look at that. So now I'm setting the central point at 50 pixels along, 100 pixels along, and 50 deep. Now remember, this whole screen is 320 by 480. So in Gideros, I basically work directly in pixels, although you'll see in a moment that there's a bit of a sophistication beyond that, but basically I'm working in pixels directly when I draw my 2D objects on the screen. There's another convenience function as well, as instead of using setX and sety, I can also set position in a single go. That does exactly the same thing as what it did a minute ago. I set the position of the sprite at 100 by 50. So these are just some of the methods that you have available for a sprite. Now I've said background is a sprite. It's actually a bitmap, but bitmaps inherit from sprite. So all bitmaps have all the features that sprites have. And if you go to the API manual, the Gideros reference manual, you'll see all the different features that, all the different methods that sprites have. The sprites have lots of methods. Won't surprise you, perhaps. So we've already seen adding a child, and we've seen some of the set APIs. So there we can set the x coordinate and the y coordinate. Okay, let's delete these because I want to leave my sprite at its default position, namely at 0, 0, and I want the anchor point to stay at the top left corner. I'm now going to add another sprite. which is a ball. I'm going to add the ball to the screen. And it's exactly the same process. Bitmap.new, texture.new. In this case, I want the bitmap to be called ball.ping, one of my other bitmaps. So I've now created a new bitmap called ball. Again, I have to add it to the stage to make it appear. And again, I'm going to do it in exactly the same way. Now, let's go and see what that does. So there's the ball, and it's drawn on top of the stage, on top of the background. So you have to realize that the order you add things is important, because I added the background first, and then I added the ball on top of that. That's why the ball appears in front of the background. I could reverse the order. If I add the ball first to the stage, and then I add the background, then the ball will be drawn first, and the background will be drawn on top of it, which means we won't even see the ball. So sometimes it's not convenient to add things. You can add things in the order you want them to appear, like this, and that's fine. But sometimes it's more convenient to add things in a different order, or to change the order without having to have the commands in a certain order. And the way you do that is there's another API called add_child_at. So let's say I've added the ball already, but I want to add the background behind the ball. I can use add_child_at background, 1, which is saying the background should be in position 1. And that forces the ball forward into position 2, so the ball will be drawn on top of the background. Even though my first command was ball and the second command was background, I should still see something. Okay. So you can do things in that order. I'm going to put them back the way they were. But the point is, you have various different options for adding children to the stage, or for adding children to their parents, because every child can have children as well as the stage. The stage is just a special sort of sprite, but it actually acts like any other sprite. So I'm going to add the background first and then the ball, and that's my program. Now, the next thing I want to do, of course, is to make this ball move and bounce around the screen. To do this, I'm going to create some new fields within this object called ball. Now, the ball is what's called a Lua table, and it was created using this factory function, bitmap.new. We've already seen that ball has various methods associated with it, like setX, we've already seen that one, and so on. But as well as having various methods, I can add new methods of my own, or new fields of my own, very easily. So I can say ball.xDirection equals 1. What I'm doing here is I'm creating a new field called xDirection. Now, xDirection has no meaning to Gideros. This won't cause the ball to move by itself. It's just a convenience function that I'm using for my own programming. And notice how I can add things on the fly like this. I can add new methods and new fields on the fly without any special type of declarations. Let's go ahead and do ball.yDirection. And these directions will just dictate whether the ball is moving, in this case, to the right or left, and in this case, up or down. So we start it moving to the right and down. Some other information is the speed of the ball. Ball.xSpeed. I'm going to set this to be 2.5. This is really just a constant because it will never change. The speed in the x direction is 2.5, and the speed in the y direction, I'm going to take it to be 4.3. And it might be worth noting at this stage that Lua only has one type of number. It doesn't have integers versus floats or anything like that, or doubles. It just has numbers. So this number, it happens to be an integer, but actually it's just a number. So the primitives in Lua are numbers like 4.3, 3.4, strings. I could easily set x speed to be a string, and you can have true and false as well. And there's this important thing called nil, which turns out quite a lot. So whenever something's invalid, it will be nil. So you do need to check for the presence of nil if you're running a function, it gets the wrong value or an inadequate value, Or for example, if you open a file and it doesn't exist, it will return nil. So nil is different from anything else. And roughly it's the same as false. So these are the different primitives you get in Lua. So now what we've done is we've set these new fields to be different values, and these are going to be very useful when we're writing the code to do with moving things around. Now, to make the ball actually move, we need to write a function. I'm going to call this function onEnterFrame. Now, this is how you write functions within Lua. Notice we don't have to specify the return value of the function or anything like that. Nothing has to be explicitly typed in Lua. A function ends with the end statement. So the body of this function, what's going to happen is this function is going to be called every 60th of a second to make the ball move. So what it will have to do is it will have to interrogate the current position of the ball, update that position, and set the new position of the ball every time it's called. I'm going to create some new variables called x and y. X will be set equal to getX. So ball.getX returns the current x value of the ball. So now I've got the coordinates of the ball. Now I'm going to increase these coordinates every frame. X equals x plus ball.xspeed times ball.x direction. So if you multiply these two together, it's just equal to 2.5. The ball's going to advance 2.5 pixels every time I run it. Every frame it will advance 2.5 pixels in the x direction. And similarly, the y coordinate of the ball is also going to advance in the same sort of way. So if we try running that, what will happen? Let's see. Okay, the ball hasn't moved, it just stays where it is. So why is that? Well, the reason is that this onEnterFrame, it doesn't have any special meaning for Gideros. Gideros doesn't know about the function onEnterFrame as having any special meaning. We have to register this function as a function that Gideros needs to call every 60th of a second. We do this by doing the command addEventListener. And in Gideros jargon, a listener or an event listener is a function that gets called whenever an event occurs. In our case, the event we want is the EnterFrame event. So what we're going to say is every time there's an EnterFrame, every time the screen is redrawn, we want this function to be called. So we want the onEnterFrame function to be called. This should now cause the ball to move, because every time a new frame is drawn, Lua will call this onEnterFrame. The Gideros system will call onEnterFrame, and the ball should move. Well, so far we haven't set the ball's position yet. We've only advanced a local variable called x, and x has no meaning to Gideros in itself. So this won't cause the ball to move. We need to set the coordinate of the ball equal to this new x. Ball set x, x. Ball set y, y. Now the ball should move, hopefully. Let's have a look. There it goes, off the bottom of the screen. Of course, we want it to bounce around the screen. So to do that, we're going to have to do some if-then statements based on the x and y coordinates. If x is less than 0, then zoom in on that. Ball dot x direction equals 1. So the ball is coming off the left side of the screen, which is 0. We want it to change direction and go to the right. And then the next time round the loop, x direction will have been set. The ball will now start moving to the right. If x is greater than, now I said the width of the screen was 320, but what if I were to do that? Let's just see if this would be right. x direction equals -1. Let's try running that. You see the ball didn't actually bounce. It will bounce. Let's make it go a bit faster. Let's make it go 5 pixels per frame. Yep. You see it did bounce, but it waited till it got off the screen before it bounced. Why is that? Well, the reason is to do with this anchor point detail again that I've already mentioned. The coordinate of the ball is its top left corner, right? So what we're saying is when the top left corner of the ball gets all the way to 320, then it should bounce. But by that point, the ball's gone all the way off the screen. We really want the ball to bounce when it's about here. That is to say, 320 minus the width of the ball sprite. So we don't want it to be 320, we want it to be 320 minus some width. So what is the width of our ball sprite? Well, fortunately, Gideros will tell us with another API. Ball get width, which takes no arguments. And now we should see the ball bounce off the right-hand side of the screen in a more satisfactory way. Let's see if it does that. Yeah, as soon as it touches the screen, it bounces. And it bounced off the left as well. It didn't bounce off the top and bottom of the screen. And of course, to achieve that, we will have to write equivalent code. Let's do that. Okay, if x is less than 0, then I want the y direction to be +1. If y is greater than the screen resolution, 480, minus the height of the ball, right? Get height. There you go. I want the y coordinate to be going upwards. Yeah, go upwards to -1. That should do it. So we've written a bit of a program here. Still a very short program, of course. Let's see if it works. It should bounce off all sides of the screen, and it can never leave, so it bounces around. And there you go. So we've written a very simple program. And this is how it would actually look on an old iPhone, 320 by 480 iPhone, which is fine. But what happens if, let's say we want to run it on an iPad? Well, with this Gideros player, we can try running it on different hardware from the hardware menu. If I choose the resolution, let's say it's a regular iPad, 768 by 1024 resolution. That's what an iPad looks like. If I run the program on an iPad, it doesn't look very good, does it? We don't really want the screen to be mainly empty. We don't want these big empty areas. And all that's happening is the entire scene is being rendered, 320 pixels and 480 pixels are being used, but the rest of the screen is not being used. So what we want is for the app to run on the entire iPad screen. Now what I don't want is to go through this code and have lots of if-then statements which dictate the actual resolution of the iPad and say, well, if it's an iPad, then I must bounce when I get to this number of pixels. If it's an Android phone, it must bounce a different way. Fortunately, Gideros allows you to write the code only once, and it will automatically take account of the resolution of your mobile device. How does it do that? Well, there's this concept called the logical dimensions. In our case, the logical dimensions of the app are 320 by 480. But Gideros can be made to scale the app onto the screen however big it is. So you write your code in Lua purely against 320 by 480, but when it comes to play it on the app, Gideros detects how big the app actually is and stretches it onto the entire screen. So why isn't it doing that at the moment? The reason is we haven't told it to within the Properties menu. So let's go over here, right-click on the root, Hello Ball, and select Properties. We now have this Properties menu, and you can see the scale mode is no scale, which is exactly what's happening. The app is not scaled at all, it's just appearing at the top left. But if I change that to stretch and select OK, then it will work. It will fill the entire iPad screen now. Let's try that again. You can see the app is now filling the entire iPad screen. And similarly, if I want to try it out, let's say a low-res Android device or a basic Windows phone, 480 by 800 pixels is typical. you can see that the app will run like this, and again fill the entire screen. But what you can see is that the ball is somewhat distorted because it's been stretched to different extents in the X and Y direction. That's because the aspect ratio of the actual screen of my device, this Android device with 480 by 800, is different from the logical resolution, which was 320 by 480. To overcome this, there are different scale modes you can think about. So I have stretch scale mode as one option, but I can also choose the letterbox scale mode, which means it will scale up the scene as much as possible without distorting the aspect ratio. So what you'll get is a letterbox format where you have black lines at the top and bottom of the screen. Just like you see when you're watching a movie on a TV, different aspect ratio, and you have to have these black lines to see the entire movie. So I set it letterbox now. I set OK. Let's run this again. Here it is in letterbox mode. You can see there are indeed these black, or rather white bars at the top of the screen, which are basically wasted space. But the app is stretched as far as it can, so as to fill as much of the screen as it can, while not distorting its aspect ratio. And what you would normally do in practice is you would have a bitmap for the background of your whole game, which is big enough to fill any extra bits at the sides. So you would make this field.ping a little bit bigger, and the user would not be aware that this white space is happening, and they would look very nice. So you can, typically people choose one of these two modes, either stretch or letterbox are very popular, and there's several others which are similar as well. So basically you just write the code once against the default resolution which you set here. So you set the logical dimensions, in this case it's 320 by 480, which is the default setting, but you can change this. So you can change your logical dimensions to be anything you want. So you might set it to be 100 by 100, in which case your pixel coordinates are actually percentages. So you can choose anything that's appropriate. And then you write your entire Lua game against this dimension 320 by 480, and Gideros will automatically scale it nicely to run on any device. So when people download it on the Galaxy tabs or their iPads or their iPhone 6s, it will just look nice on every single device it runs on. You don't have to worry about that as the programmer. That's one of the nice things about Gideros. Okay. Yeah, I said I would just have a quick look at this Gideros gproj file. We've already written some code. The gproj file just consists of a list of the files you want. So there's no magic about the gproj file. It's just a text file, and it just contains all the files that are actually in your project. It also tells you things about the logical dimensions and things like that. So we've already discussed that we can have we've set logical height to 480 and so on, and our scale mode is in here somewhere as well. So just to prove again, you don't really need to look at this gproj file, but just to prove it's a very simple text file which simply keeps track of all the files in your project. The one more thing I want to mention at the moment is the print statement, which is very useful for debugging because eventually something will go wrong, and you'll need to find and interrogate what's going on in your program. So let's try printing something out. Remember the anchor points detail? Let's say I forgot what the anchor points are. Let's say ball get anchor point. So I can just say something like this. I can have a string to remind me what it's all about. I can say print anchor, and I say ball get anchor point. That will then return two numbers, which I can view in the output. So you can see the anchor point is 0, 0, and the printout appears in the output pane, which is very useful typically. The other thing I want to mention is this box at the top and the way that you can run on different devices. And this is a very exciting feature of Gideros because at the moment I'm testing my app on my PC, right? It appears in a window which happens to have the right resolution corresponding to the device I want to see it tested on. But I can actually test it directly on a real device. And the way I do that is I have to install a special app for each platform. So I have an Android app, for example, which comes with Gideros. Let's have a look at where that is located. I'll just terminate this for a minute. Now if you go to where you've installed Gideros, normally in Program Files, Gideros, you should find that there's an APK. An APK is the package that's used on Android, and eventually when you generate your own Android games using Gideros, you'll want to export an APK file. But there's already one here which is called the Gideros Android Player. To install it on your Android device, all you do is you drag this across onto your Android device using a USB cable. Once it's on the Android device, you can use a special app from the Google Play Store called Apk Installer. So let's go to... There are other apps you can choose of the same sort. There we go. It's a free app available on the Google Play, and it simply allows you to install an app that you've dragged onto your device. So you drag an APK onto your Android device, you run this app, and it will install and launch the app on your Android device. So what you've done by that point is you've installed this Gideros player. When you run the app, it just looks like this. It's just a sort of blank white screen with some information on it. But what you'll also notice over here is that you'll see a choice of different things that you can choose to launch the app on. Now at the moment I'm saying this is going to run on my computer called Swiss. But if I had an Android device connected to the same network through Wi-Fi, the Android device would also appear in this pull-down menu. I then press play, and the app will launch directly on my Android device. So I can choose whether to launch my app on my PC, as I'm doing now. I can launch it on an iOS device, I can launch it on an Android device, I can launch it on a Windows phone, and so on. And in fact, with this icon over here, I can launch it on all the players that are available at once. So having made a quick change to my code, make a change to some of the numbers, I can just press launch on all devices, and it will actually launch the app on all the devices, and I'll see all the devices running my enhanced code and see what effect it had on the code. So this ability to run instantly and test instantly on all these devices over Wi-Fi is one of the great advantages of Gideros. Now the technique for installing these various players on each device does vary with each player, with each operating system. So for Android, as I've said, you just need to drag this APK onto your device. It's very simple to do and install it that way. With Windows Phone, it's you have a zip file which you need to decompress, and you need to use a special program to do it, to install the Gideros player on your Windows Phone. And this is all documented. Let me see, if I go to the Gideros website, you will see some documentation for how to install these different players. It varies with each operating system. So deployment to device, you can see when you come to install your Gideros player on Windows Phone, you need to use these various programs that Microsoft provides you to install it on the Windows Phone. The most complicated one is iOS, actually, because we can't provide you with a binary package for iOS. We have to provide you with an actual project, which you then import into Xcode, compile, and connect your iPhone or iPad and launch it all within Xcode. But the details of how to do that is given in this documentation. So the point is you can install players on all your devices, whether it's iOS, Android, Windows Phone, and you can launch your app directly on all these devices within Gideros Studio. And you can see how they'll work directly on a mobile device. Okay, well that wraps it up. That's the very first tutorial. I've introduced the basic concepts of Gideros, how to program in it, where the different parts are, how to install it, and so on. So, thank you very much.